Hi, welcome to Engineering, and today I'm going to teach you how to do the frame analysis on Prokon. So what we're going to do is go into the Analysis tab on Prokon, and we're going to select Frame. Our frame will open, and you'll see it open on the General tab. So here we can name our truss, which I've already done, which I call truss, and this is where we're going to start our design. Now, in this video, I'm going to use this example as my reference. So I'm going to try and design this and show you how to design this. So you'll see that this is a structure. It's got two fixed supports. It's quite a complex truss where the spacing is 2,500 millimeters between the different points. There's a UDL. There are three forces acting on it. So this is a very good example that I'm going to use to try and show you how to design a truss. So what we're going to do is we're first going to go to the nodes. Now, just to illustrate to you what the nodes look like, nodes are basically the points where the beams connect to each other. So you'll see on this drawing I made, I represented all the nodes I'm going to make on the truss. And these nodes are going to be used to make the beams, which can make beam sections, which we can actually analyze later. So we're going to start with 1. So 1 I'll put at the coordinates of x and y of 0, 0. So this is going to be my origin. So my origin will be at 0, 0. So that will be where everything is referenced from. So if I say my next y is 2 meters higher, it'd be 2 meters higher than my 1. So that's just how I do it, that's how I design it, that's my preferred way. You can choose another point as your point of reference, but that's what I do. Alright, so now I've specified that I want 5 nodes on the first column on the left hand side. So what I'm going to do is I'm going to say the number of, and this is where you basically say how many nodes are there extra to the node that you've made. So I'm going to make 4 because it's 4, or I have 5 nodes in total, and there are 4 additional nodes. Now you see node increments, I'm going to make 1. The reason I do this is if I made it 2, then it will make every next node another count of 2, or another increment of 2. So it'll be 1, 3, 5, 7 instead of 1, 2, 3, 4. Alright. So that's what I'm doing. So that's my node increment. And then I have my x and my y, where I can specify if I want my design to be in the, like I want the spacing to be in the x direction or in the y direction, and how far. Since we're making it vertically go upwards, and it's already, according to the design, it's 4 meters high already, I'm going to make it a meter between each gap in the y direction. Remember, if I can show you on the design, y is upwards, x is on the horizontal plane. So y is my vertical, x is my horizontal. So now I've got spacings of 1. You can see I've done the first column. So yeah, that's just a good way to show you the first part. Now what I'm going to do is I'm going to start my next part, which is going to have my top chord, which is 6, 7, and 8. So what I'm going to do is I'm going to put in node 6. My node 6 is now a different spot to just a 0, 0. It is 2.5 meters from the 1 to the right, and it is 4 meters, actually 4 plus 1, so it's 5 meters above. So what I'm going to do is I'm going to say that it is 2.5 meters, 2.5 meters to the right in the positive direction, that means to the right, and my y is going to be 5 meters. Now my 6 should be in the right position, so now you can see it's gone up, and now my 6th one is there. Now I want to add 7 and 8 as well, so I'm going to add 2 nodes extra, so it's going to be 7 and 8, and they'll be increments of 1, so they're only going to be counted 7, 8 instead of, for example, 8, 10. give us 2. And now I've got a bit of a situation where it's going to be 2.5 meters for every x direction, but it's going to go up by 1 meter each time. So what I'm going to do is I'm going to say my x is 2.5 and my y is 1. That looks pretty good. So you can see it's 5, 6, 7, and 8. It's gone up. That matches my drawing that I have. Now I also want to make 9, 10, and 11, but I want to show you a different way of doing it. A simpler way, but it takes a bit longer. So I want to make 9, 10, and 11. So I'm going to have 9, 10, 11. Those are the 3 nodes I want to make now. Now I have to determine each one's coordinate. That's a different way you can do it. So 9 will be 2, 5, 7.5, 10 points, 10 meters away from 1, and it would be a total of 4 plus 2, so 6 meters above. So my 9 is going to be 10 meters and 6 meters. Same for number 10. 10 will be, we have it here, so basically 2.55, 7.5, 10, 12.5, and it would be 5 meters above. So it would be 12.5 and 7 meters above. Sorry. 5 meters, sorry. Alright, so now we've got our truss, our top chords, and yes, then we just need to do 11 as well, which is a total of 14, not 15 meters to the side, to the right, and it is only 4 meters above the ground. So it would be 15 meters, and it would be 4 meters above the ground in the y direction. So now we've got our 11. So now we've got our first column and the top 2 chords of our truss. Now we can also do the bottom part, the bottom chord. So that's 12, 13, 14, 15, and 16, where we would start our 12 at 2.5x, and it will be 4 meters y. So 12 will be 2.5 in the x direction and 4 in the y. So now it's probably level with 5, and that's what we want. But now we want an additional 1, 2, 3, 4 nodes. So what we're going to do is going to say number included 4. We're going to have increments of 1, and then it's only going in the x direction 2.5 meters every time. We go to our sketch, we can see 2.5 meters every time. So now we've got our bottom chord. You can actually see the shape of the truss forming properly now, so we've got the whole shape. Okay, so now I have to do the last part, where we have 17, 18, 19, and 20. 17 is 3 meters above the ground, and it is 15 meters to the side. So we're going to say that it's 17, 15, 3. Now we should have our 17 over there. By the way, if you do point to the nodes, you can actually see the x, y, and z. Z will always be 0 in this example because we're using the xy plane. Look at my description for the settings that I'm using. Alright, so now we'll have number of, so we'll have just 3 increments of 1, and they'll be going down, so it'll be negative 1 meter. Alright, now we've got the nodes, so we've got the shape of our truss. Now we can go to the next step, which is our beam. So we've got the beams, and the beams are very easy. All you have to do is you have to say how they are connected, so with a dash. So we're going to have 1, 2, 3, 4, and 5 connected, so we're going to say 1, dash 2, dash 3, dash 4, dash 5. And you see all the points are now connected with a line. We can do this with our top chords as well. So we're going to have 5, 6, 7, 8, 9, 10, 11. So we can say 5, 6, but instead of doing the entire root, we can just say double dash 11, and now we have the whole top chord. That double dash basically means continue the same way we've done the first two. So it's 5 to 6, so it's gone from 1 to the next highest node, and then double dash to do that until 11. So that's what we did there. Now we can also do that for our bottom chord. So we'll say 5 to 12 to 11. Let's see if that works. Alright, now I'm going to do the last few of the bottom chord. So we're going to say 12 to 16. So it's going to be 12 to 13, double dash to 16. Now they are connected. Since it struggles with the numbers, we're also just going to say 16 to 11. There we go. And then just for our column, 11 to 17, 17 to 18 to 20. Okay, now that we've done the outside framework, now we have to do some of the inside framework. So you'll see in our design, in our sketch, we've got members inside. So let's first do our vertical beams or components. So we're going to do each of these vertical ones. As we saw, they're all connected. So we're going to have 6 to 12, 7 to 13, 8 to 14, 9 to 15, 10 to 16. Now we want to connect these intermediate ones, so we'll have those ones connected. So how we're going to do that is we can do it all in one line. We would say 12 to 7 to 14. Okay, so to 7 to 14, then to 9 to 16, to 9 to 16. We've got our intermediate or inside members. So that is great now. So we've got all our beams. We showed the shapes where they are, but we still have to name them. So what we're going to do is we're going to go back to the top again, and we're going to give a name for each type of member. So you'll see you'll be able to select the drop down list, but we haven't created any names yet, so we can't select anything. So we're going to start with 1 to 5, which will be our column, which I'm just going to say COL. Then we've also got 5 to 11, which are our top chords. So I'm just going to call them T chords. Right. So now that's our T chord. Now 5 to 12 and 13 to, actually this whole bottom row will be our bot chord. So I need to name each one after that name. So that, and then 12 to 16 as well. Now what you can do is you can go to your drop list and you can actually select ones you've already made. So I'm going to make my B chord for that as well, and then 16 to 11 as well. You start seeing they're changing colors here for what the program thinks each thing is named. You'll see the intermediate members are also named or also green, but it will be changed soon. Now 11 to 17 is part of the column, so I'm going to make it COL. And then 17, 18 to 20 is also a column. 6 to 12 will be diagonal chord, so I'm going to call that a diag, just for short. 7 to 13, actually I'm going to name all these members diags, just as our intermediate members. You'll see now why this is useful. And the last one's 12, 7 is also going to be diagonal. Alright, so why we named these members is because it's very important when you want to do your beam sections. So when we go to beam sections, you'll see columns the first option. Then we just add the rest of our coordinates, or rest of our names. And what we're going to do now is we're going to specify for each of these types of beam sections what shape code or dimension of a beam or steel or concrete or timber beam are we going to associate with that. So you'll see when we start with our columns, you select the row or select that space, beam section designation, and you'll go to sections. And for this example, we're going to use an I-beam of 245 by 146 by 31 IL. And you'll see it automatically gives you the values for that section. If I quickly press the 3D button, you'll see that the member that I just specified has already been shown there. So you can see a 3D view of that member that's already been named. So what I can do now is I can go to the next section, the T chord. I can also specify section, but now remember that you get steel options, you have concrete options, you have timber options as well. So what I'm going to do is I'm going to make my top chord timber just for the example. I think it would probably be a very impractical design, but let's go for 7373 rectangular. Alright, then it also automatically puts in the values. By the way, the materials you can change. I'll make a small little video just to show you how to do that. It's very important. Then for our bottom chord, we'll make it steel again. We'll make it I as well, or let's make it H. And then we have 254 by 254 by 73 H1. And now you can start seeing our design is starting to show clearer and clearer. Our timber is very small for our top chord, but our bottom chord and our columns seem to be fairly good shapes. So let's maybe go back to our T chord, go to our sections, timber, and let's make it maybe a much bigger shape. So let's make it 140 by 600, and I see that's way too big. So yes, if you don't have specification, use trial and error to try and get a good design. 70 by 300 might look a bit better. Alright, so that looks quite good. It's maybe not the best design, but this is just for example. Now all we have to do is the diagonal beams inside, or our intermediate beams. So I'm going to make them angles. So I'm going to go to the steel tab. I'm going to select maybe this angles and 100 by 65 by 8. Alright, now you'll see the design looks pretty good. It's maybe not the best design, but you can see the materials or the sections that have been associated with it. You can also see the properties of these materials or of these shapes. So after that, now you've noticed I've skipped cables. I'm also going to skip shells and solids because they're not very important for this specific design. But in the future, I might make more videos where I show a bit more accurate designs with using those properties. Okay, now we're going to go to supports. You'll see on my design, I specified it must be fixed support for both the supports. So what that means is it'll be supported in the X and the Y direction. So it'll be at node 1 and also node 20. So those will be our two supports. Now we have to specify the fixity. Both of them are going to be XY. So both of them are going to support the structure both vertically and horizontally. You'll notice there's a small cap Z, And when you do it in 3D, there'll be small caps X, Y, and Z. The small caps basically supported in a rotational direction, while so around that axis in that rotation, while the caps or capital letters will specify in just supporting vertically or horizontally. So once we've done that, we can go to our nodal loads. Now these are the loads that actually act on a node. So you'll see on this design, we have 3 points that act on the nodes. So 5 kilonewtons on that node, which will be up node 5. So what we're going to do is we're going to say on node 5, we have kilonewtons of 5. Now why I selected PY is because it's in the Y direction. So that's a point load in the Y direction. And it's also going downwards. But before we can continue, we need to specify a load case. Now load case is basically the type of scenario where that load is applied. Some buildings have different, or most buildings actually should have different scenarios of when a load is applied differently on that structure, or different loads are applied to it. But once I've done that, I'm going to turn my 3D off. Now you see there's 5 kilonewtons, but it's acting upwards, while in our diagram it's acting downwards. So what you're going to do is you're going to say our PY, our point load in the Y direction, is a negative. Now you see it's going down in the negative direction. We also have one acting on the top node, which is node 8. And it's also acting in a negative direction of 10. So now I've got the 10 there. Now all we have to specify is the 4. So the 4 will be positive because it's going upwards, and it will be in node 14. Now all these things are assumed to be on load case 1 because we haven't changed the load case since. So you see it says load case 1 and it shows all our load cases on it at the moment. Alright, once we've done that, we can go to our beam loads. And this is now the loads applied on the beams, not on the loads themselves, the nodes themselves. So we're going to select load case 1. And now we'll see that we have a UDL acting on this side of our truss. So that side is 8, 9, 10, 11. So we're going to say 8 to 9, double dash 11. Now we must specify if it's X, Y, or L direction. So X will be just going horizontally, Y will be going straight downwards, while L will be going onto our beam itself. So since we can see that's going onto the beam itself, we can select L. We're going to select W low node. Because it's only a few nodes, it's not that, and we use the low nodes function. If it was a large amount of nodes, I'm talking about maybe 50 nodes, then we would use the WH high or the W high node. So the low node, we have it at 10 kilonewton per meter. So we're going to say 10 kilonewton per meter. And now you'll see the force acting, but it's acting upwards, so we've got to make it negative, negative 10. Now you see that it's all acting downwards on the beam. So now we've got that load, it's on load case 1, put in our nodal loads. So now we've put in everything that this structure has specified. Okay, for our last step, we'll go to analysis. And this is where we say start analysis to actually analyze our structure. There's a few errors or warnings. That's fine. We can just say continue. And once the analysis is run, it will show you what's going on with the structure. You'll see the structure is deflecting to the right direction and also going a bit downwards if you compare it to the original structure standing. So now we can go to our outputs, and we can see we've got our deflections, which are already shown by default. we've got our reactions, which is 19.43 and 37.75 on the one side, and 10.57 and 48.25 on the other side. So these are reactions on our supports in both the X and the Y direction. Then we also have beam forces. Now this shows how much force is acting on each member, or what each member is supporting. The blue and the red both show either tension or compression. Red being compression, blue being tension. So yeah, it shows the values there, and that's very important when doing calculations or further calculations. Right, so those are the basic steps. I'll maybe add more videos showing different parts of the frame analysis. That is the first one you can use for now. Please like and subscribe and support our channel. We're trying to assist or trying to educate engineers. Thank you very much.